Hello, ladies and gentlemen. Today we're going to be talking about triangles and angles. Our first standard in this brand new unit is all about angle relationships both inside and outside of triangles and how we can set up and solve problems involving angles both inside and outside triangles. We are in a brand new unit that is all focused on properties of triangles, characteristics of triangles, theorems about triangles, congruent triangles, anything and everything you ever wanted to know about triangles. That's where we're starting. Our guiding question for today is, how can I solve problems with angles both inside and outside of a triangle? First, before we start practicing with some practice problems and like actually solving for numbers and solving for x and all that good stuff, we have to remember how to classify triangles or name triangles both by their angle measures and by their side lengths. In the left-hand column, there's 4 ways that we can label, name, classify triangles by their angle measures. The first way is called equiangular. So we call a triangle equiangular if it has 3 congruent triangles. We call a triangle acute if it has 3 acute angles in it. So any angles that would measure less than 90 degrees. We call a triangle a right triangle if it has specifically 1 right angle in the triangle. And then we can also call a triangle obtuse if it has, again, specifically 1 obtuse angle or an angle that measures more than 90 degrees. In the right-hand column, there's 3 ways we can classify triangles by their side lengths. If a triangle has 3 congruent side lengths, all measuring the same distance, we call that triangle equilateral. If a triangle has 2 side lengths that are congruent, we call that triangle isosceles. And if we have a triangle that has no same side lengths, or all 3 side lengths are a different number or a different distance, we would call that triangle a scalene triangle. We have some theorems that we're going to write down today, 2 of which might be new to your brains, and then some more fun facts, maybe is a better way of saying it than theorems. The first 2 we're going to be using quite a bit in this class, and that is specifically what today's lesson is focused on. But the other 4 below it will also help you if you remember those little tidbits too. The first is called triangle sum theorem. It says that the sum of the measures of the angles in a triangle is 180 degrees. So if you have an acute triangle, a right triangle, or an obtuse triangle, it doesn't matter. All 3 angles in that triangle will add to 180 degrees. The exterior, let me erase that. The exterior angle theorem says the measure of an exterior angle of a triangle. If we have a triangle with one side extended out past the triangle, they're referencing this angle as the exterior angle. That angle, that exterior angle, will be equal to the sum of the measures of the 2 non-adjacent interior angles. So this angle right here would also be adjacent to the exterior angle right there. They're saying that the exterior angle, this angle right here, is equal to not that one, but this angle plus this angle. So if we look at those 2 non-adjacent interior angles, and let's give them some numbers. Let's just pick some easy acute angle measures. So let's say this one's 50 degrees and this one is 70 degrees. From what we know about triangle sum theorem, all 3 angles in a triangle have to add up to 180. So if we take 180 minus 70 minus 50, we should be left with 60 degrees. We also know from our information about linear pairs, these 2 angles, that exterior angle and that 60 degrees, a linear pair should add up to 180 degrees. So if we take 180 minus 60, that should get me back 120 degrees. What the theorem is trying to tell you is that without knowing that that inside adjacent angle is 60 degrees and without using triangle sum, you can jump straight to this exterior angle 120 will be equal to that 70 plus that 50 degrees. Okay, we'll look at some examples where it will make a little more sense. The fun facts or the other like adjacent theorems that we can know is that acute angles in a right triangle will be complementary. So 2 angles that are not labeled 90 degrees in a right triangle will also add up to 90 degrees in order to equal that 180 total. There can be at most one right angle or one obtuse angle in a triangle, which makes sense, right? If you had two right angles in a triangle, you wouldn't actually be making a triangle, you'd be starting to make a square. And then, of course, you can't do that with obtuse either because you need it to add back to 180. Each angle of an equilateral triangle has a measure of 60 degrees. That also makes sense, going back to the triangle sum theorem. If you have an equilateral triangle or an equiangular triangle, in order to take 180 divided by 3, you'll get back to 60. If two angles of one triangle are congruent to two angles of another triangle, then it must be the case that the third pair of angles are also congruent. That's kind of common sense. Okay, we have 4 example problems today. The first being an example where we have to classify triangles by its angles and its sides. They gave us 3 ordered pairs. Let's plot them on our graph. So A was 0, 8, B was 3, 3, and C was 7, 3. Let's plot them, connect them, and label them. In order to classify a triangle by its angles, we would ultimately want to get out a protractor and measure the degrees and all that stuff. But if we also just trust our eyeballs, we can see that at angle B, this angle being created is measuring more than 90 degrees. So I know for sure that we have an obtuse angle in this triangle. So I'm going to know that at least when we classify this triangle by its angles, that it's going to be obtuse. But when we go to classifying by its sides, now we actually have to find some values for the side lengths. The first side length that's easy to find is BC because we can just count the distance on the graph. It's 4 units long from B to C. From A to C, I'll just go to the next longest side. If we go back to Pythagorean theorem, and when you learned Pythagorean theorem, you can make a triangle over here. So you'd have 1, 2, 3, 4, 5 units on this side, and 1, 2, 3, 4, 5, 6, 7 units on this side. So that's how I got the distance formula for D is equal to the square root of 7 squared plus 5 squared, my X distance plus my Y distance. That would be the square root of 74. That doesn't break down, so the decimal would be 8.6. We said this was 4. If we do the Pythagorean theorem again for the distance from A to B, this would be 3 units, and this would be 1, 2, 3, 4, 5 units. The distance from A to B or B to A would be the square root of 3 squared plus 5 squared, which is the square root of 34. Also not a nice number, and that would be 5.83. So now we know that this triangle has 3 distinct different side lengths, which makes it a scalene triangle. So our final answer in classifying the triangle would be it is a scalene obtuse triangle. You could also flip the order and say an obtuse scalene. All right, example number 2. This is tying back to our triangle sum theorem. Triangle sum theorem, which said all 3 angles must add to 180 degrees. So that's what we're going to do. We're going to take angle A, which was 2x plus 14, plus angle B, which is 64, plus angle C, which is 6x plus 14. All has to equal 180. That's how we're going to find the value of x. Once we know the value of x, we can plug it in for our measure of angle A, and then we can find the actual numerical value for the measure of angle A. 2x plus 6x is 8x. 14 plus 64 plus another 14 is 92. Subtract 92 from both sides, you get 8x is equal to 88, meaning if we divide 88 by 8, we should get 11, not 10, sorry about that. 88 divided by 8 would be 11. We also wanted to find the measure of angle A, so we're going to plug what we found for x, which was 11, into the x spot in that expression. So we're taking 2 times 11 plus 14. Measure of angle A will be 22 plus 14, which is all equal to 36 degrees for the measure of angle A. All right, example number 3. This is the exterior angle theorem, which read that, let's go back. Exterior angle theorem said the measure of the exterior angle of a triangle equals the sum of the measures of the two non-adjacent interior angles. Okay. This exterior angle, the angle existing on the outside, will be equal to the sum, which means we know we have to add stuff together, of the two non-adjacent interior angles. So this angle is the adjacent interior angle to that 20x. They want to take 7x plus 5 plus 60, the two non-adjacent interior angles. 7x plus 5 plus 60. So we get 20x is equal to 7x plus 65 when we combine our like terms. Oops, get all of our x's on one side. 20 minus 7 is 13x, which is equal to 65. Divide by that coefficient to get our final answer. 65 divided by 13 is 5. And they also wanted us to find the measure of angle ABD, which is the exterior angle. Measure of angle ABD would be taking 20 times what we found for x. So the measure of angle ABD would be 100 degrees. Those are my two answers for x and the measure of angle ABD. Number 4, which is our last problem for today. It says the measures of the acute angles of a right triangle. A right triangle. So let's draw a triangle with a right angle. Here's my 90-degree angle. It's triangle ABC. They said the measure of angle A is x squared plus 48. Measure of angle B is 3x plus 32. Those are the two angles that are acute. That's what they said. So that means that point C is our 90-degree angle in the triangle. That's going back to the fun fact of knowing if we can always use triangle sum. We can always default onto triangle sum, and we can do 90 plus x squared plus 48 plus 3x plus 32 equals 180. The shortcut is, if we were to subtract off 90 right away from that 180, the measure of angle A plus the measure of angle B will also just be equal to 90. So that's the shortcut, is x squared plus 48 plus 3x plus 32 is equal to 90 degrees. Again, if you forget this shortcut, you can always default back on a triangle sum and do x squared plus 48 plus 3x plus 32 plus 90 equals 180. We're just skipping a step in solving. Let's get it in standard form because it looks like we're going to have to factor. With that x squared plus 3x, 48 plus 32 is 80. We need to get one side equal to 0 in order to factor efficiently. 80 minus 90 is a negative 10 equals 0. We now have it in standard form, which means we can set up our parentheses. We need two numbers that multiply to a negative 10. So we have 10 and 1 or 5 and 2. I would assume you're going to need 5 and 2. And those two numbers have to have the right signs to add or subtract back to a positive 3. So if I do a positive 5, negative 2, those two numbers, plus 5 minus 2, when you multiply them, we'll get back to negative 10. When you take plus 5 minus 2 and add them, you'll get back to a 3x. We're technically taking these factors and setting them equal to 0 and then solving the one-step equation. And that's how we're getting our solutions for x. So x equals negative 5, x equals a positive 2. We're talking about angle measurements in here, so when you plug it back in, you better be getting a positive answer. So that means that my final answer only works with x is equal to negative 2.